Restoring a Bing Clockwork Train Part 11, Making New Buffer Heads. If you've been watching the rest of this series, you will know that I made a complete new set of buffers for the locomotive. I didn't have anything to work from other than a photograph, and I made the buffers for the engine spring-loaded. But the ones on the carriage are definitely not spring-loaded. These are the originals, and most of the parts are missing. One of them is actually intact though. So at least I have a pattern to work from. The first thing to do is to look at the angles of the parts. As you can see, the shaft of the buffer stock tapers. This doesn't pose a problem. I can just offset the top slide to get the taper. But for the head of the buffer, I don't think I need to offset anything. I can just change the angle at which the tool cuts the metal. But first, by way of an experiment, I'm going to make what's called a form tool. I've ground one of these tools to a special shape to make a form tool. And as these are carbide tip tools, it's worth remembering you cannot grind them on a normal grinding wheel. You have to use what's called a green grit wheel. And it's called a green grit wheel because it's green. But it's a very hard substance and it grinds carbide tips. I'm not actually making a buffer head at the moment. I'm using a piece of scrap metal in the chuck to just see whether it works. And it's a different principle to using a normal lathe tool because the surface area that's doing the cutting is very wide. And as you see it here, the tool isn't ground to the proper profile yet. It's not far off, it just needs to be ground slightly differently. It's just a matter of trial and error and having a good eye to make sure that the form tool is the correct shape. But first of all, it's a quick trip to Blackgate Engineering to buy some metal of the correct diameter. So I arrived at Blackgate Engineering, bought the metal and drove home again. This sequence is obviously speeded up, and please be aware I did observe the speed limit. Before I went up to Blackgate Engineering at the alarming speed you've just seen, I measured the diameter of the original parts to make sure that I arrived home with the correct diameter bar stock. In this clip you can see the difference between the unground tool on the left and the ground tool on the right. I really did remove a lot of material, including some material from the sleeve of my jacket. Look at this, health and safety in the workplace. In the outer part of my workshop I have two bench grinders. The larger of the two has a polishing spindle on one end, but the grinder that I always use is a very small one. It has two 5-inch grinding wheels, one on each end. And if I apply too much pressure to the wheels, they just stop, which is a good thing so that my hands will not look like this. Here are the two pieces of bar stock I bought from Blackgate Engineering. One is steel and one is brass, and both of them are 9/16 of an inch in diameter. I'm not going to use the form tool for making the buffer heads after all. I'm going to use the form tool for making the stocks. I'm just using an ordinary round nose tool mounted facing towards the work in the outer part of the tool holder. And this seems to be okay for turning the tapered part of the buffer heads. By the time it's finally cut to size and polished, it should look okay. A quick comparison with the original buffer head tells me that I'm definitely somewhere near, and the length is also correct. Well, almost. I'm just making some very fine adjustments to it. And by taking fine cuts for the final cut, I get a good finish. I'm only going to show the making of one of the buffer heads. The rest will be exactly the same. And as usual for parts of this type, first of all, centre drill, then drill tapping size, and here I'm threading the resultant hole 5BA. On the original I do believe it was metric, but I'll use 5BA because it's more or less metric anyway. A lot of the thread sizes used in model engineering are very close to metric, it's just the pitch that's different. And when I think about it, I don't really know why I don't go metric all the way, because the actual bolts are much cheaper than BA sizes. I didn't thread the 5BA hole all the way into the buffer, because rotating a chuck by hand is not the most sensitive way to cut a small diameter thread in a piece of steel. So I held the buffer blank in a pair of pliers, and then I used a tap wrench, which means I'm not going to break off the tap if I do it that way. After threading each of the 5BA holes, I cleaned the tap. I got rid of any metal residue in the flutes. And once again, by doing that, it lessens the risk of breaking the tap off in the hole. I now need to mount this blank in the chuck the other way round, and I suppose really I could have left it attached to the tap, but instead I'm using a long brass bolt, and that way if the brass bolt shears off inside the work it's going to be very easy to remove it, just by drilling it out. For this next operation you need a very steady hand, and all the cuts have to be fine, and yes, I know it's not fully concentric, but it's near enough. And as I've said many times in the past, I'm not making parts for a satellite. This is not a high precision item. I'm rounding the edges of the buffer head using a file, and don't forget when you file in the lathe, keep your fingers well clear of the chuck and always make sure the file has a handle. Finally, to finish off the first of the buffer heads, I just take another fine cut with the round nose tool and touch it again with the file. And then once again, the wonderful Proxxon machine tools come into play. These are absolutely ideal for doing this sort of thing. I'm using wet to dry sandpaper followed by Scotch-Brite, and just look at the finish. And that's it for this video. One buffer head made and ready to fit, and 3 more to go. Thanks for watching, and I hope you found it useful.